Yeah, so, getting started with local AI development, or, GenAI made simpler by being able to use Docker on your local machine. That's what we're going to talk about today, right? We're going to go in and we're going to look at the functionality that Docker has available today to let you build local AI powered applications, whether or not they're going to run locally, or if you're just prototyping before you hand them off into a cloud service provider. You can save a lot of money, a lot of resources by using local instances in advance of consuming cloud instances. So first thing, people are out there like, Docker, why are we talking to Docker, right? That Docker desktop's just a GUI for running containers, right? It's just, well, I mean, it's a lot more than that, right? So the first misconception is we are just a GUI, but Docker desktop specifically is a whole suite of tools, right? It's the Docker daemon, and there is a GUI, and there is a CLI, but it's also Docker Compose, and it's Docker Build, it's Docker Scout for security, and test containers for testing, and all of this stuff. The part that we're going to focus on today, though, is Docker Model Runner and Gordon, and something called the MCP Catalog and Toolkit. So we're going to look at those features specifically and how they can be leveraged to run AI-based applications. So let's talk about Docker Model Runner. Docker Model Runner allows you to run AI models on your local machine. So if you're familiar with llama.cpp, we basically encapsulate llama CPP, and we provide you an OpenAI API compliant endpoint. So if you have code that you ultimately want to run in a cloud provider, and that cloud provider supports that API, that all you literally need to do is change the URL for the LLM endpoint, right? The large language model endpoint, the API endpoint, and it will work. So the important thing here is that these AI models are not running in a container. They're running natively on the system. They take advantage of GPU acceleration. If you are on a MacBook, which is what I am on right here, you can't see what I'm pointing at, but I have my MacBook on one side, and I have my Windows machine on the other side. My MacBook has Apple Silicon, so I can run Docker Model Runner there, and then my Windows machine has NVIDIA hardware, so I can run Docker Model Runner there. The other thing that we do with Docker Model Runner is that we offer a way to package up AI models and put them into Open Container Initiative artifacts, which means they can be pushed and pulled to Docker Hub. So, for instance, the format that we work off of is GGUF. So you go to Hugging Face, you grab a model, and you say, oh, I want to use this model. And it's in GGUF format. And you can then use Docker model, the Docker model command to package that up. And then you can Docker push that model onto your Docker Hub account. So maybe you fine tune it or whatever you do, and then you go push it up there. So that's what the artifacts are for. Do you support direct Linux like Ubuntu or RHEL? We are going to. I'm not sure where we sit on that today, but I don't want to say I'm 100% sure, but I'm 95% sure, because what we're doing in Linux is you have to install the NVIDIA CUDA drivers into the Linux VM. So you could do that just as natively on Ubuntu. I don't know about how RHEL handles that, but with Ubuntu, yes. I'm 99.5% sure that works that way. All right, so let's talk about Docker Model Runner in Docker Desktop. Let's take a look at it real fast, right? So the very first, I'm going to hide this dialog. The very first thing that you might want to do is you might want to go out and pull a model, right? So if you don't want to do your conversion, if you don't want to go out and find one, right, we have a bunch on Docker Hub that are available to you straight away, right? And you can grab one of these models that you see fit, and you can pull it. I'm not going to do that because, as you can imagine, these are gigabytes in size and it takes a little bit of time. But if I was to pull that model, and I can do that way, or I can do it with a Docker model pull. I can pull it from the command line as well. if I spell pull correctly or model correctly. I can then go in and I have those local models and I can interact with them right here on my machine, right? I'm actually going to do, this is the one I'm using in my demo. So I'm going to use Llama. How are you? Now, this is running on the Apple Silicon. I have 18 gigs of VRAM and it's an M3. So it's pretty responsive, right? I'm a computer programmer, so I don't have feelings or emotions like humans do. Some humans lack emotion. And it will just interact with me, you know, right? The way you would expect it to. So you can go in, you can see the requests that have been sent to the LLM, right? You can see the prompt, you can see the metadata, how many tokens it used, why it stopped, all of that stuff. You can view the actual request, right? So you can get that model, the user context role, all back and forth. So if you just wanted to have a chat bot, that is one way to use it, right? That's not the best way to use it. All of the stuff that I was doing here, I can do on the command line too, right? So I can do Docker model run, actually Docker model list, and I can do Docker model run AI / llama 3.2. I think I can do latest. I think this will work. To latest and see if that, oh, well, it just took latest as my question. I guess because I didn't put a tag on it. Right. So now I'm in the chat mode. Hello, do you have emotions? And it'll come back, no, I'm just a large language model. I don't have any emotions. So that is the baseline. This is not NVIDIA. This is on my MacBook. This is a MacBook Pro M3 with 18 gigs of VRAM. And then on my NVIDIA machine, I have an NVIDIA 5070 on my Apple machine or my Windows machine. And if we have time, I can maybe go over there and try to do some demos on that as well. All right, so that's Docker Model Runner as sort of an interactive application, right? But that doesn't really let us build it. That's not building an app, right? That's just using it. So before we build an app or we go into it, I want to talk about how actually AI apps actually get bigger, right? And I definitely will increase that screen size for you. Let me go back, Command Shift. There you go. And let me go. We'll do it when I go back in there. Okay, so let's talk about how AI applications, actually work under the covers, right? This is a getting started presentation after all. So when you write an AI application using Model Runner, Bill, is there any way to turn off the notification tone? Because every time like I start to talk and then we get a notification, it's kind of a little anyway.
Oh, sorry. You still get some what kind of notifications?
Well, every time someone puts something in a chat, it beeps on my computer, like I'm getting a tone.
Oh, the chat beep.
Yeah.
Okay, let me see.
Yeah, if you can, if not, no worries.
Okay.
Yeah. So in a chat application, the way it works under the covers is that we go in and we have some front end where we write a question, right? That goes into the application specific AI, some API you've written, right? So I have an API call and an API on the back end. This is an API that I write. That API makes a call to Docker Model Runner. It does that just by using a standard OpenAI API call. So I go in and I say, hey, how's the weather today? Docker Model Runner gets that and says, oh, what model do you want? Oh, you want this model. So you can have multiple different models running under Docker Model Runner as long as your hardware supports it. And we can go in here and we can run this model and then we'll get some sort of response back and that gives us an answer, right? That's the loop. So this is where Docker Model Runner fits in. Again, nothing here is running in a container. This code is just running in the Docker Model Runner client but there's no containerization in here. We are going, so now when you work with large language models, there are several different ways to kind of get them to do what you want, right? And all of that comes down to having them understand the context, right? The meaning of what you're saying. The idea here is that when we are in a conversation, right? If I were to say to you, I'm going to go buy an apple. I'm pausing so you guys can think about that sentence. That could mean a lot of different things, right? Two that immediately come to mind are I can go buy an Apple computer, or I'm literally going to go buy an apple, a piece of fruit, because it's lunchtime. So if someone said, what are you having for lunch? I'm going to go buy an apple. Oh, right. I should still be going to buy a computer on my lunch hour, but probably I mean the apple, right? I probably am going to eat it, right? Or if I say to someone says, yeah, I heard you're getting a new computer. I'm going to go buy an apple. I'm probably talking about the computer, right? And that is all based on the framework, the where I'm at in that moment. What's my historical knowledge, right? What all of these different things. Context and meaning and similarity are relevant to some piece of information. It is not, it's not absolute. It's a completely a relative thing. So why am I talking about this? We do this every day, right? We do this every day. If I was to say to you, my car won't start, you would go back in your memory and you would say, well, geez, what are the things related to car problems have I experienced? I once had a dead battery. One time I ran out of gas. One time the engine was making a funny sound, but the car ran, but then it didn't start later. We found out that I had a loose belt. Right? My brakes squeaked. Well, that had nothing to do with it, right? So all of these things are sort of ranked in the way that my brain might think about a car not starting problem. The most obvious one to me is the battery was dead, right? That would be the first. If someone said my car won't start, first thing I said, oh, you probably had a dead battery, right? That's what I would go to. So I ran out of gas, more likely, not as likely, not at all likely, right? Kind of going down that list. So let's see. Can I use Docker and AWS EC2 and also build a chatbot? You can use Docker and EC2. If you want to use Docker Model Runner, you would need to have an EC2 with the GPU, and I would tell you it would just be cheaper to probably use something like Bedrock to do it, right? And this talk is focused on desktop stuff, right? It's not really focused on cloud stuff. So that's another tangent. And then, Mr. Widget's points about the quantized models, you can see that in the Docker desktop right here. So this is a Q4 quantized model. These are all Q4. These are all quantized to 4-bit and K medium, right? And these are smaller models. So quantization is taking the idea of taking a model and refactoring it so it's smaller. You lose a little bit of accuracy, but the trade is a much smaller model. Notice that all of these models are well under the 18 gigs that I have on my system. So they will all fit, as was discussed in the chat, in RAM. Yeah. Smaller equals faster. Right? Smaller, so it's smaller equals faster equals less accurate. But the degree of accuracy, depending on what you do, may be imperceptible. You may not ever notice it, depending on what you're building. So, all right, so the slides, right? So this idea of context and meaning. So as you may or may not be aware, large language models are essentially AI models trained on a bunch of data that are really, really good at guessing about what you're talking about. Does the LLM model load into VRAM or RAM? It depends on your system. On the Mac, it's shared memory. On Windows, it is dedicated memory. All right. Document was for running the model themselves. Given. Okay. All right. So retrieval augmented generation. So I said there's a bunch of different ways to get information into the model. LLMs are really good at predicting whatever the next word is in a sentence, right? That's how they derive content. They look at what you said, they figure out what you kind of mean, and they go and they figure out an answer for you. But LLMs have some limitations, right? LLMs are trained at a point in time. They only know what they know. They're trained on publicly available data, right? So if you want to know something that happened more recently, or if you want to know something that is specific to your business, your information, you have to give that information to the LLM. LLMs can be coached by using a prompt, right? You can write your prompt better. That makes the LLM more responsive, creates a better response. Adding your own data is part of that prompt, right? We'll look at that. So how do you do that, right? So this is a two-step process. You need to convert all of your data into numbers, and those numbers are called vectors. Vectors are why I have an information systems undergraduate degree and not a computer science undergraduate degree, because I didn't understand them. So I am not a vector mathematician, but I'm going to explain to you how they're used in a way that hopefully you can understand. So when you build a retrieval augmented generated app, which is what we're going to look at today, you just do normal chatbot stuff, but you have to put your data in the mix, right? So let's go ahead and take a look at what vectors are. So vectors are a collection of numbers. If you were an engineer and if you were an engineer or somebody who programs, a software engineer, you're probably familiar with the idea of arrays, right? That is like a two-dimensional vector, right? You can have three-dimensional vectors. You can have n-dimensional vectors. So imagine these things just floating in space that you can't comprehend around your head, and that's why I am an IS major. So these numbers represent meaning. They represent context, right? And the more dimensions they have, the more nuance they have, the more meaning they can have. So the way you measure similarity between two pieces of context, two ideas, is by doing vector math. So if two vectors are closer together, that means they are more similar in meaning, right? So if we look at that diagram, which is a very infinitely simplified version, let's say that we have an apple and we have banana and we have cat. An apple and banana is represented by the vector 020700105. That vector, if you did the math, the difference between that vector and vector A is smaller than the distance of the vector, the math, vector C to vector A. So vector C has a larger vector than vector A. B may be larger, but closer. So that distance, those lines, is how, it's not just like how far away they are from each other. It represents how close they are in meaning, right? So when you take your data and you convert it into vectors, you're separating it into a bunch of different buckets based on what it means. There's a bunch of different ways to do this. That's way outside the scope of this discussion, but suffice to say, you chunk it up, you run it through an algorithm, you get vectors. Can you provide more perspective on? I have to see Priyanka's question. I'm sorry if I'm missing questions because there's so much like chatter that they're getting lost. So the question was, let's do it this way. If you put a question in and I haven't answered it, I'm asking you to please put it in again, because in the diagram you showed earlier, what would we miss if we take away the Docker model runner as the model is running directly on Mac? You would need some other way to run it on Mac, right? So you have to have a way to serve the model. The question, the follow-on question about why not use Ollama or LM Studio, it's just choice, right? So if you are already developing in Docker, you have Docker tooling, you have Docker Hub, you have that ecosystem. So that's why you would use Docker Model Runner. Ollama is fantastic. Trivia, the guys that founded Ollama were the people who wrote the initial versions of Docker Desktop. They used to work for Docker. I worked with them for 3 years back in the early days of Docker. Ollama is fantastic. You'll never hear me say anything bad against it. But if you want to stay in a Docker ecosystem, then you would use Docker Model Runner like that. My question was based on the chat completion. There is a connection labeled Docker OpenAI API linking to Docker Model Runner node GenAI app API. So in that slide, we're actually going to see that in the code, Evelyn. If you see the code and you don't get it, then let me know, because we will cover that when we look at the code. But the gist is that the way you talk to a Docker Model Runner hosted model is through the OpenAI API. So that API is a standard for talking to large language models, whether they run on OpenAI or not. They can run in Ollama, they could run in Docker Model Runner, they could run in Hugging Face. OpenAI API is a standard for interacting with large language models. It's a standard that we speak. Llama CPP is a way of storing those models, or serving those models. Okay, so if I want to store a bunch of my own data, right? So I would take all of my support data. I would run that through an embedding model. This is not an LLM, it's a different model. And that embedding model would spit out all of those numbers, right? So now just realize that I've got a database full of vectors sitting over there off the side next to my LLM that is a source of information. Yes, we will 100% show the code, 100%. So if you go in and you look at what happens now in the search for Retrieval augmented search, which is what we're going to build. This application is a support chatbot. I want my support chatbot to know about my support data for my company. So what I have done is I have taken that support data and I have put it into a vector store. So that is setting out there on my system. When the question comes in, I have to convert the question into a vector so that I can compare the question to the vector store, right? So I get a vector from the question, then I run a function that basically says, hey, return to me the 5 closest pieces of data from this database that relate to this question. None of this is using the LLM yet. The LLM is not involved yet. This is basically vector math. This is it going, and my question is this. And when I look for similarity and I draw a circle, these 5 things are within that circle. So I'm going to return those. Now, when I send the prompt will be, you are a support expert. You are a support engine. You're a support chatbot, an expert on our software. You are working with a support engineer to answer customer questions. Use the knowledge of the tickets provided to form an answer to the question. So the LLM will be the one that does the logic, but it will do the logic with what it knows about the world and my support tickets, because it doesn't know about them by default. So this is what a reg app is. I can absolutely send the slides to Bill. And then the previous slide. Yes, the previous slide is, this is a process that happens outside of our reg application. This has to happen at least once. You're not using any open API keys. There's no API keys involved. Yeah. So someone said, do we have security issues if we're using an API key? I'm just looking at all the messages. So you actually, to make the, well, we're going to get answers to all of these questions. All of these questions are going to get answers. Okay, so this is what we end up with. Now, I want to show you something here. These two models, these two outputs were absolutely created by the same prompt, the same application. The only difference was the model they were sent to, right? So when you choose your model, you can end up with much deeper answers and much shallower answers. The one on the left took longer to create. The one on the right was quicker. To me, the one on the right solves the problem. So you'll want to evaluate a bunch of different models to do this for you. All right, so let us go ahead and talk about, okay, yeah. So now we're gonna get into the code. So all your questions will be answered. All right, so first of all, on the API keys, you do not use an API key with Docker Model Runner. It is not necessary because you're using your local machine. If you wanted to switch to OpenAI, you would need an API key for them. Securing your API keys, people do that every day. Every application that communicates with an API that is secured needs an API key. So that's table stakes, right? So you would secure that however you would secure that normally, right? So this is the code. We have a front end. Let me actually show you the app running real fast. So I have the app running here in Docker. I have a front end. If I click on that, this is the support chatbot. I'm going to ask it a question. User cannot log in. Right? That's just, I'm going to tell it. That's the problem I'm having. So right now it's communicating with the back end. So let me show you how it does that while that's going. All right. So this is the main code, right? So we go in and we provide an environment variable through our Docker compose file. So let me show you that. So we're basically saying, oh, sorry, it is in an env file right here. So we say, look, this port runs on port 8000. The front end's on 8501. The API host is API. This is API up here, right? So it comes in and it grabs the path to be able to communicate with the LLM, and it grabs and it sets the LLM name. So all you need to know to talk to the LLM in Docker Model Runner is the URL of that LLM, and that URL is different whether or not the LLM is running or whether or not your application is in a container or not in a container. You can find that in the docs, and the large language model you're going to use, right? So then we go in and we've set up the API call. Now, this is our metadata. So this is our support tickets. They were in JSON format. I ran them through an embedder and they came out in something called Facebook AI Similarity Search. And Angela, I think, was asking, how big is that file? So if we do ls-al data, ls API data, and then let's put the AL in front of it so we can see the size. This is, what is this? 1.5 megabytes, right? For, I think it's 1,000 records. So it's about, so it's not a ton. Okay, so in the main.py, right? So we grab those files and we load that all up in there. And then we go in and we need an embedding model. You need to use the same embedding model to be able to take the user's question, right? So remember, we were in this step here, right? We have to translate the question. This embedding model has to be the same as this embedding model. So otherwise, you're using two different models to translate text, and you'll end up with different vectors, right? Because they're not being transformed the same way. So we transform that, right? All right. So we're going to go in and we are going to grab the question, right? So this is the chat bot. If someone hits the chat endpoint, we're going to go ahead. This is a little like if I wanted to clear the memory. Someone could send a message that said clear or reset, and that would clear the memory. We'll talk about that in a second. And this is how we get the vector for the question. This is basically saying it's one thing. Take that message from the user, send it into the embedder, and that becomes the query vector. And then we can go in, and this is how we find the distance. We're saying do a search on our index, which is what we loaded up top of our support tickets, right? Our index. So we load it up into the index and we say, show me the 5 closest models. Top K is defined as 5. Somewhere I forgot to show that, but this says, give me the 5 closest models, right? Then we come in and we say, look, I don't want anything that is irrelevant to my discussion. So remember I said that distance is similarity. So what we do in the code is we say, look, if the best case, if the closest one, top score, if top score, the closest one, is farther than the farthest distance I specify, which in our case is 1.2, then we couldn't find anything relevant, right? So how does that manifest itself? So here, let's go back to our chatbot. So this is the support ticket. So yes, so in the support index.afs is the vectorized data in the RAG. Yes, exactly. Yes, exactly. So in the support chatbot, this is the answer we gave to user cannot log in. This is how that was sent to the LLM, right? So remember, it went and grabbed the top 5 tickets. So it went to the support database and grabbed those 5 tickets. We had told it, you are a support agent, you are answering questions for a support engineer, you have access to support tickets that may have answer the question, use only the following tickets. If they show an issue was blah, 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 right? And so what it did is it said, okay, what was the question? User log in. Okay, let me go search the database. Well, I found these things on user cannot log in, and then it came up with an answer. So the max distance was 1.2. So if I said, what is Bitcoin? I can't find any relevant support tickets. That is because the max distance between the question, what is Bitcoin, and what would they found in my database was greater than 1.2, because there's nothing in my database about Bitcoin. If I turn off the RAG and I don't send it to the database, so now I'm just straight up calling the LLM. I am not using the support ticket database at all. I'm just sending a straight up question, right? What is Bitcoin? It will answer that question, right? Because it's not looking at my support database. It's just using the chatbot to do it, right? So let me go back here real quick while that's running. So that is where this comes from. If you ask a question and there's no support information, there wasn't anything in the database close enough, right? There was nothing close enough to be able to give me any relevant support tickets. If there is, I take those support tickets and I add them and I call them context, right? So I go through and I take all of that and I compare them into the JSON. I get the full ticket out of the JSON. And that is what you saw in there. This is the prompt that gets sent to the LLM, right? So it has the conversation history, it has the user message, and it has the context, which is those support tickets. So embed the question, grab the support tickets, pull them out. This vector database is Facebook AI similarity search. That's what I'm using, right? You could use PG Vector, you could use Chroma, you could use Pinecone. Yes, it's exactly, Evelyn. It's FAISS. It's Facebook AI similarity search. That is an in-memory database that's great for local stuff. If I wanted to persist this, if this wasn't a demo, I'd use Pinecone or Chroma or something like that. All right, so that is that, right? So now it knows about Bitcoin, right? Because I didn't send it any support tickets. There are no support tickets in this thing because we didn't use RAG for context. So it's just a straight up call to tell the chatbot. You have to run the first side. No, you don't. The first slide step, because it's in memory. No, it's the database is held in memory right here, right? It reads this file into memory. This is the file. You don't have to do that first step every time. It's right. Yeah. If I needed to update that support data, right? So I probably have a cron job somewhere that takes all of the day support tickets, vectorizes them, and adds them into that database, right? But this is a demo, so we don't do that. All right, so let's go back to the slides. So that is, and so what you didn't see in there was anything that had anything to do with Docker, right? So where's the Docker part of it? The Docker part of it is really not a Docker part of it at all. The Docker part of it is the base URL. It is just sending the request to the Docker model URL, which is HTTP localhost port 12434, right? That's the URL. You can get that URL, or you can get that port from the settings in Docker Desktop. You don't have to start the model. You don't have to stop the model. You do have to download the model, but as long as the model is on your machine, all you have to do is make an API call to that model's endpoint, or to the Docker model runner endpoint, and the model will start up and answer your questions. It does not have to be reloaded. Harry, it does not have to be reloaded. The vector data gets loaded one time in the app, right? It's in the disk. It's on the disk. Yes. So Docker's core is not containers. Docker's core is development, is developer experience, right? So we work with containers, but we also work with a bunch of other stuff, right? Like security, and it's container adjacent. So the new feature is Docker model runner, and there is actually more new features. And that's why I'm kind of speeding up, because I want you to see a couple other things really fast. So I'm going to jump back to those so we can get through them. But Docker model runner, it runs large language models on your machine. All you need to connect to it is the Open API AI endpoint, which is there. Yes, because Ollama and Docker Model Desktop are two separate programs, so they don't use the same format. They don't share the same universe. So if you're running something in Ollama, it's for Ollama. If you're running something for Docker Model Runner, it's for Docker Model Runner. They could be this exact same model, but you need to make each one of them aware of them. And there's no way today to cross-contaminate them. All right, so let's jump back into the slides. All right, so one way to make LLM smarter is to give it a better prompt. The other way is to give it data specific to what you're asking it. The other way is to get it to call a tool, to call it some piece of code, right? And that is usually done something called function calling. And function calling is the ability for you to say to the LLM, hey, look, I wrote a little bit of code to go along with this application. So if you get a question about time, know that you have this function that will tell you the time. You don't have to call the function explicitly. You just have to write it as the developer, and make the LLM aware of it. And you say, all right, LLM, you've got this tool for calling time. Now, if somebody was to ask the LLM, what time is it in New York? The LLM has no idea by itself, right? Because it doesn't have any current data, but it can find out that it goes, well, do I have any tools that can do that? Yes, I do. I have this tool. So it will use that tool, send it back to you. You'll make the call. It'll send it back to your code. The LLM grabs that information and it responds to your question, right? So that is what function calling is, tool calling. And you'd almost be ready to do that. The problem is that there's no standard way of doing tool calling today, or there wasn't until about 6-8 months ago, right? If you wrote a time tool, someone else would write a time tool, someone else would write a time tool, right? This is where model context protocol comes in. Model context protocol is a way for you to take tools and standardize them, right? And you have something called an MCP server, and that MCP server sits out there, right? And just like we went to RAG to get information, you can go to the MCP server to get the information. This is a way of using additional tooling to make your applications smarter. MCP servers define a standard way of packaging and distributing these tools. So now vendors can host, like GitHub hosts an MCP server at github.com that you can call over HTTP. You just need to let your application know where the MCP servers live, right? And so with but there are some challenges with this, right? There are a bunch of MCP servers everywhere. There's some on GitHub and there's some over here, and you saw one on a Discord channel, right? And they're put out by companies, and some are experimental. And how do you know you're getting one you can trust? So that's where we created the MCP catalog. The MCP catalog takes these MCP servers and it packages them up as containers that we build and that we sign and that we stand behind. We know what's in this MCP server, just like a Docker official container image knows what's inside a Docker image, right? We know because we build them. That is what the MCP catalog does. But there's still some challenges, right? So now we get a standardized distribution, right? Now we can use the same mechanisms to get our MCP servers as you do for your containers. So you can now run MCP servers as containers, pull them down and use them. You don't have to worry about setting them up locally. So if you grab an MCP server off of GitHub, most of the times you're either going to run a Node or a Python package manager to install a bunch of dependencies and then call the MCP server if it's running natively, just like you would with an application. But in a container, it's all self-contained. So you don't have to worry about any of that runtime setup. You don't have to have that tooling in your environment. And because they are under the influence of Docker and they're in our registry, we can apply access management policies to them. We also handle things like secrets and credentials. So if you need a secret to get into something like GitHub, you can store that in Docker Desktop encrypted, and that will be used to access your GitHub repository. So that is what we do in the terms of ensuring that you're getting quality MCP servers that you know you can trust, that are in a way that don't have an impact on your environment, right? Because you can run them in a container, so you don't have to install anything extra. And we allow you to deal with things like secrets that can be sticky. Now, I just talked about that. I'll show that in the demo. So that's how we store some of those problems. Now, the one thing, this is a little bit tricky to talk about, and there's no good way to show it. So bear with me. If let's say I wanted to write an application that would take, it would look at a GitHub code base and it would open Jira tickets for any issues that had been submitted to that GitHub code base. I would need a GitHub tool and I would need a Jira tool. If I was not using the MCP toolkit, I would need to have both of those servers running independently, right? They would both have to be able to be accessible. With Docker's MCP toolkit, what we do is we use something called the MCP gateway. And so when you look at your MCPs that you have enabled, all three of these MCP servers are behind one endpoint. So rather than having to stand up 2 or 3 or 4 different MCPs, I can just say Docker run MCP gateway. That stands up all of my MCPs, right? So I have one for GitHub official, right? And so in the configuration, I can use OAuth or I can use a personal access token. So that is what those are. And then I can integrate this with a bunch of different tools, right? You can integrate it with your code, or you can integrate it with existing clients. And that's what I'm going to show. So I'm going to come here into Gordon, and I'm going to say new conversation. And I'm going to say, do I have any private GitHub repositories? By default, Gordon has no idea about my GitHub. but I have a tool for it, right? I have in the MCP toolkit, I have check repository, right? So it knows how to use that tool to find my private GitHub repositories. So it's going to go through and it's going to make some tool calls. It's going to call about me to figure out who I am. And then it's going to go and look at my GitHub repositories. And I have 14 of them, of which you own 13. And then I could say, is my GitHub pirate private? So again, it can go out, it can look at that repo for me because it has the tools, because it has the MCP gateway, right? Well, actually I do, so it failed, but I do have one. I could also be like, create a new public repo called AI Camp Webinar. And I'll misspell camp, but that's fine. And so that will go out and it will create the repo for me. So that is using MCP servers through the MCP gateway. And with that, I can also integrate that into Visual Studio Code, which I have done. So if I come in here and I do a Command-Shift-P to get the palette and I list servers, I have my Docker MCP gateway. If I list the configuration, all I had to do was basically say, standard IO means it's going to communicate locally on my system. So it's running locally, and Docker MCP gateway run. That starts up all of my MCP servers. So if I go Command-Shift-P and I say list servers and I say Docker MCP gateway and I say start, that is going to go out and it's going to start those servers, right? So it discovered 104 tools. We go back here. Oh, sorry. We go back here. We had 107 because this has Docker Hub and that one doesn't, but that's where that comes from. And then here I could go to Copilot and I could be like, do I have any private GitHub repositories? And it would go off and it would use those same tools to do the call, right? So, and then I could also use a different tool. I have do I have it turned on? I have to look and see real quick. No, I want this, and I want. So there, it built the repository that we started. And if I go back into tool and I go back into servers, I have like DuckDuckGo, right? I could be like, can you search the web and find information on Docker model runner? And that should go out and use the DuckDuckGo search and find information on Docker model runner, right? So there is, right, that's it using DuckDuckGo to go out and do the searching. So there was a couple questions. There was one question in there about, what about fine tuning? Yes, fine tuning is absolutely another way you can get LLMs to respond in a way you want them to. Fine tuning is the process of taking an existing model and layering your own training data on top of it. It's much more lightweight than training a model from scratch. That is another way to do it, right? Fine tuning, RAG, prompt or context engineering, and tools. Yep. IAM is an overloaded term. So Prakash is like, IAM is used in AWS. IAM is what AWS calls identity and access management. We use IAM as an acronym for image access management. So it's the same acronym, but it means two different things. But all of it's related to the same thing. It's all related to access management. So how does it decide what tool to use? That is something that boggled my mind. The LLM knows that it doesn't have the capability to answer the question. So what it then does is the LLM says, okay, well, I don't know that I have the ability to answer this question, but I do know that I have the ability to call tools. Let me see what tools I have. And then it uses its LLM logic to look at the question and look at the available tools. And sometimes you can do things like I did. If you were like, notice I was a little tricky here, right? I said GitHub repositories. So that would be like, well, I have this tool about GitHub. So maybe I can use that. And here I said, can you search the web? And he goes, well, this tool is about web search. If I go to Docker, if I go back to Docker Desktop and I go into Ask Gordon and I start a new search. Oh, that's not what I wanted to do. Wow, that worked too. If I went in here, I said, do I have a repo called BLE? It's probably going to default to a Docker Hub repo, right? Not a GitHub repository, because that's exactly what it did. It was like, you do not have a Docker repository, right? The repo was generic enough. So what it did there, Dave, in that scenario, it was like, no, the question is about a repo. A repo is something associated with Docker Hub, and I have this Docker Hub tool, and I can search with that, because it didn't have enough context. If I had said, do I have a GitHub repo? Then it would be like, well, I don't know that natively, but I have a tool for GitHub. I can call that tool, and that's what it does. Boom, boom, boom. MCP has 100% introduced significant security problems. That's one of the reasons you want to use a service to get your MCP servers. How does it handle conflicting tools? Say weather.com and myweather.com. And when a what's the weather today question comes. So the only reason you would have conflicting tools is because you have enabled conflicting tools. So it's just going to pick one of them based on whichever one it thinks is best. It's just going to be like, oh, it's a weather question. I have 2 weather tools. I'm just going to call this one. It's going to do some logic to make that decision. The simplest way to avoid that is to just have one weather tool, right? Or what you do in your description, you say, myweather.com, a tool for doing long-term weather forecasting. Weather.com, a tool for doing short-term weather forecasting. And it could then look at that and be like, was the question about a 10-day forecast, or was it about a 3-day forecast? And it might do it that way too. So, I actually did say I said access management when I said it, Harry. I said our access management policies. All right. Anyway, so, all right. Well, we are at time, and that is all we have. How do we add any of this? So yes, so there's one more slide. I'm going to put it in the chat. There's one more slide here. And that is my GitHub repo. I'll put that in the chat. That's all my source code for this. The way you enable AI features in Docker Desktop is you have to turn them on. They're disabled by default. Your companies may have them turned off if you're using a company Docker Desktop subscription, because they are beta features, but they are in the beta features. This is Ask Gordon. This is Docker Model Runner, and this is MCP Toolkit. All of those are available to you right there. All right. So, yeah. Thank you so much for attending. You can get a copy of the recording from Bill, and we will talk to you next time.